necessarily think you need to write these down, just understand. If you want to add two functions together, all you do is add the individual components. And that should make sense. And when we look at this, you'll be like, oh, that's fairly easy. When you want to subtract two functions, once again, you subtract the individual components. You subtract and add like terms. When you multiply two functions, you're going to multiply the individual components. You might have to FOIL here, okay? And then quotient, you're going to divide the two. Biggest thing here you need to understand is that g of x cannot be 0. If it's 0, that's undefined, and you can't find the quotient. So let's go ahead and look at this. Okay, it says given f of x equals x squared plus 4x, g of x equals root x plus 2, and h of x equals 3x minus 5. Find each function and its domain. The nice thing about this problem is that it's got multiple parts. So those instructions at the top will follow you through for the next like 3 or 4 examples. Okay, so the first part we're going to look at is finding f plus g of x. Okay. And so if we remember back to that table, it said if I want to add f plus g together, I'm just going to add each of the individual components. So this is essentially what it means. That is what it is defined to be. So all I'm going to do is I'm going to plug in what f of x is. F of x is x squared plus 4x. What is g of x? Can you combine any terms? Are there any like terms there? No. So that is going to be your final answer. Now notice what it says. It says to state its domain as well. So remember, domain means what values? X values. So we're thinking what x values make sense here. So are there any x values that will not work in x squared? So I'm looking specifically at this part. X squared will take all values, right? You can square every number. What about take a number times 4? You can take every number times 4, right? So far we're good. How about here? Can I put every number in there? Every number, but if I plug anything smaller than -2 in here, I'm going to get the square root of a negative number, which I cannot have. So my x values have to be greater than or equal to -2. So that's what your domain has to be. It has to work in all parts in order for you to include it in the domain. So even though all the numbers work in the first 2, it doesn't matter because it fails in the last one. So that last one causes us to restrict it to x is greater than or equal to -2. So let's look at this one. Once again, same instructions. This is just f minus h of x. Okay, so exact same problems, f minus h of x. So if we think back to that first slide, this is going to mean f of x minus h of x. So all I'm going to do now is plug in each of those individual components. So x squared plus 4x, and then what? 3x minus 5. Now here's my problem, is that I've got that negative sign outside and I've got like terms. So I need to distribute that inside. Okay? And what will my final answer be? Okay? Okay, so that's my answer. Now what we need to do is find the domain. So what x values work? So let's look at this one. What x values work there? Everything. What about here? All of them. What about here? Yeah, 5. Yeah, so basically my domain will be all reals. Let's look at another one. F times h of x. So when I take f times h of x, that just means f of x which in this case is x squared plus 4x, times h of x, which is 3x minus 5. So how do you do that? FOIL. Okay? So I'm going to start first terms. What do I get? 3x cubed. Good. Let's go ahead and go with my outer terms. What do I get? Negative 5x squared. Okay? What do I get for my inside terms? 12x squared. And then what do I get for my last terms? Negative 20x. So my final step will be to add like terms and combine them. So what do I get? Plus 7, good call. And what else? Minus 20x, very good. So that is your answer. What can you tell me about the domain? All reals again, because there's nothing that's going to restrict that.
I don't get that last one.
What, the all reals?
You get that first one.
Right,
Then you say something over
the domain. That means the x values that work. So the x values that we can plug in here because this is an x. So if I look at this, can I plug in all x values here and get an answer? Yeah. Can I plug in all values here and get an answer? Yeah. Can I plug in all values here and get an answer? So that's why it's all reals. The only time you're going to have something that's not going to be like all reals is when you have a fraction or when you have a square root. Okay?
Gotcha.
So let's look at this one, and here we are. There's our fraction. So we have h divided by f of x.
I'm fine. Just
Let's see. We have h of x on the top. So I've got my 3x minus 5 on the top. What goes on the bottom? X squared plus 4x. Now, can you simplify that at all?
You take out one there.
Yeah, I could if I wanted to. So we could do that. We wouldn't need to. But if we take out one of the x's, what are we left with? X plus 4. Okay, so to be honest with you, either of those would be a fine answer. We could either answer this, or we could answer this. So then now we need to think about the domain. And this is where, if you didn't catch what I last said,
Right, that
Okay.
first one could be an answer.
yeah, this one or this one. Believe it or not, this last one we will use in the domain. So if you just hold that thought. What can't your fraction equal? Or your denominator equal? I said that wrong. Your denominator cannot equal 0. So what I'm going to do now is I'm going to find what values make the denominator 0. Okay.
This isn't gonna work.
It's actually really easy. Okay, so I either have this equal 0, or what else do I have equal 0? X plus 4, or that equals 0. So what answer will work here with the blue? X equals what? Negative 4. So what we know is that you cannot have 0 or negative 4, because if you do, you're going to get a denominator of 0. So what we need to do is we need to make an addition to these answers. Okay? And what we need to state is that x cannot equal 0 or negative 4. Okay? X cannot equal 0 or negative 4, because if it does, you're going to get that 0 in the denominator. So you do need that part to your answer. Alrighty, so now, if you look at this one's kind of a monster problem. So if I were you, I would just do f of x equals x minus 4, g of x equals root 9 minus x squared. And if I remember right, you have one of these on the test. Instructions are to find f plus g of x, f minus g of x, f times g of x, and f divided by g of x.
A, B, C, D.
So this, so this is basically like the 4 problems we just got done doing. It's like lots of points.
Holy cow. I'm just gonna headache.
So let's do the f plus g of x. What's that going to equal?
X minus 4
Yep.
plus square root of 9 plus 6.
Okay. Now we got to do the domain. So what can't x equal? Yep, we got the square root here, so now we got to look at this value. Okay, we got to think what values make that negative. So what does 3 make it if I put 3 in here for x? 3 makes it 9, so 3 is kind of my border. So I need to figure out, am I looking for values bigger than 3 or less than 3? If I go less than 3, I get like 2 and 1, right? If I go bigger than 3, I get 4. What values will make that negative? Bigger, yeah. Greater than or equal to.
So you want to go.
And then,
Between 3 and 9.
sorry, x, I wrote that wrong. X cannot be bigger than or equal to 3 because that makes it negative, right? And so we know that x can be less than or equal to 3 and it will work. Okay? So we know that x is less than or equal to 3 and that will make it work. Now we've got one other issue. Negative 3. Because if you square it, that becomes like 3. And so I need to think about, if it was less than or equal to 3, it also is greater than or equal to negative 3. So basically, it's all values from positive 3 to negative 3. Those will work. That's kind of one of those tougher ones because it's got that squared in there. Okay. Another way you could write it if you wanted to is you could write it this way. Like I said, that one was kind of a tougher one. Let's look at f minus g of x. What's the only thing going to be different versus the f plus g of x? Minus sign. Is the domain going to be the same?
Sure.
Yep. So you're just going to duplicate whatever you had in the problem before. Or remember, you could have this written as negative 3, positive 3. What? So what's the next one? F times g of x. So parentheses, yep, you're right. And then what? X minus 4. And then what? Okay. What do you know about the domain? It's going to be the exact same.
Duplicate.
Yep, exact same. And you can't simplify that. I mean, you could simplify and distribute the 9 minus x squared, but this is fine. So don't worry about distributing that. Let's look at the division.
So if it's like that, you don't have to follow.
Nope. What's the division going to be? Now, almost. Because what can't we have in a fraction? A denominator of 0. You have to take out the equals 3. Exactly right. Good call. Because if I have 3 included actually makes that 0. So I'm going to just do that. Okay, and that takes out that value of 0. All right, so now I think we're going to shift gears, and we're going to talk about composite functions. Okay. Now, these actually, I was going to say, we've done these before in the past, and if you remember, they aren't that bad. Okay, remember we called these the fog and the goth? Okay. Remember that f composite g of x means this. That's all it means. And if we were given a problem like this, we always focus on what first? Remember, I'm going to focus on the parentheses first. And so I'm going to replace g of x with what? X minus 4. Okay. Now, I'm going to take the x minus 4 and I'm going to go to the f of x function. And in place of x, I'm going to put x minus 4. So really, this would be parentheses x minus 4, what? Squared plus 1. Now, we need to simplify that. Okay, so we need to FOIL it out. Remember, there's a trick. First term squared, last term squared, and then twice the product of these two. So 2 times x times negative 4 is negative 8x. Otherwise, you can FOIL it out. But remember, first term squared, last term squared, twice the product of the two. And so when you get your final answer, it should be good. Okay, let's look at the g of f of x. What's the first thing you do? Replace f of x with what? X squared plus 1. What do you now do now? Put it in the x right here. So really I have x squared plus 1 minus 4. Good. Yep, x squared minus 3. Okay.
You just plug those in for x.
That's all you do. So this very last one is f of g of 2. There's actually 2 ways to do this problem. We're going to do it this way, then I'm going to show you another way you could have done it. But the very first thing you're going to do is g of 2. Okay. So g of 2 up here means you're going to put 2 in here. Right? What is 2 minus 4? Negative 2. So we know that g of 2 is negative 2. So now I need to know what is f of negative 2. Yeah, 5. Because I'm going to now plug negative 2 in here for x. So if I square negative 2 and add 1, I get that to equal 5. That's one way. The other way is look at the problem right above. Notice what we found. We found f of g of x, right? So what I can do is take the number 2 and plug it in here. Hopefully, if you've done this top one right, that's why we didn't start with it right away. But we end up getting 4 minus 16, which is negative 12, plus 17, which is 5. So that's another way you could have done it as well. Questions on composite functions? Okay, think we need to look at another one, or do you have the composite down? Okay. All right. I'm debating. Oh, this one. It says find two functions f and g such that the composite f of g of x equals h of x. Neither function may be the identity function. So basically what we're doing is we're saying what two functions, if I compose them, will give me this. Okay? So I know it's got to be f of g of x. So the outer function has to be what you see in the big picture. So I'm going to tell you right now, the outer function, f of x, has to be 1 over x squared. With that in mind, I want you to think, what would g of x have to be so that I will get this as my composition? What? X plus 2, exactly right. Why is that? Because if I took f of x plus 2, I'm going to put x plus 2 in here, and it'll be 1 over x plus 2 squared. Let's look at another one of those. Okay, here we go. We have x plus 5 over root x minus 1. I know this one's kind of tough. These are kind of tough to see. We're going to try them though. So I've got f of x and g of x. And there's actually multiple answers on this. Okay? What could one be? What could f of x be? Oh, x plus 5. Oh, that'd work.
Yeah.
And what would this one be? Well, no, it wouldn't work. Take that back.
Oh, dang it.
Over x.
Minus 1.
No, that won't work.
Oh, okay.
Because if you do this one as x minus 1, that's going to go in here. It's also going to go in the top. So see, that's not going to work.
Oh, it didn't work. Dang it.
So what do you think? What?
Give up.
How about I do this? Let's just change it to 5 over. Maybe that'll help a little bit better. If I just change it to 5 over that, what would be the outer function? 5 over x, good. Okay, now what do I want to replace the x with so that I get that 5 over root x minus 1? Okay, what do I want to put right here so that it looks like this? Yep, say it. Square root of what? X minus 1. That's right. Because what's going to happen is you're now going to take this x minus 1 and you're going to plug it right here. Okay, those are kind of hard to see. All right, I think you have 1 or 2 on your homework. So try and do the best you can. Here's your assignment. 2 through 12, the evens. 16 through 38, the evens. Okay, 2 through 12, the evens. And 16 through 38, the evens.